Hi, everybody. This is the second lecture on the moon. I'm going to be talking about the origin of the surface features. So the moon, we believed, had a hot molten interior, and there was a thin crust that occurred. And we can see in the bottom here a map of the years that happened. So we assume that during the period of heavy bombardment, this is when the large objects were coming in regularly. They landed, they made these huge craters. That happened. The big craters we're referring to as basins. The smaller ones are just impact craters. And after the period of heavy bombardment, the surface was still cold, but the molten interior was still hot. Then additional craters would come in and change the surface. And then we had a period here of volcanism, where the interior molten mantle would basically bubble up out through into the surface, and channels which would allow magma to come out would leak up to the top. These would then fill those basins full of lava, and that lava would solidify and become solid. Then during the inactive period, the moon cools down, and so the inactive interior basically solidifies, and those old lava beds are now what become the maria. And the ones that didn't have lava beds, we call those ones the highlands. So the Mara are basically volcanic magma that came out to the surface and froze solid. It's much darker because it's full of many more metals. The highlands are much more full of things like silica sand and lighter elements like potassium and sodium. So we have the hot interior for the first billion years, then a cool interior later after that. But after that was more bombardment, and so the Mar had a few craters, not very many, but the highland basically is very rugged with many, many craters. And that is the current origin of the surface features. So when we talk about the Mar are made up of basalts, and they're typically younger material, about 3 to 4 billion years old. And the highlands are made up of things we refer to as anorthosites, silicates, which are basically sand, but with lots of aluminum and calcium in them, as well as potassium and some other things. So this is, it's an older material, probably about 500 million to 1 billion years older than what we see in the Mar. So the Mar clearly indicates to us it's a younger material. We know the age from radioactive dating. And one other mention, there is a pulverized layer across the surface, basically called the regolith. And that layer of fine powder is all over the highlands. And it was a real concern to the missions when we landed on the moon. We didn't know how thick that regolith was. We didn't know if it was a few inches or a few feet or, you know, many yards. And that was very important in terms of landing a spacecraft on it. We really didn't know how deep that spacecraft would fall into it. So a detail of the lunar maria. This is an image of it, and we see a basaltic rock like this. Now, what makes basalts interesting, those little dark spots there, those are actually air holes. And so a basalt is very much like a pumice stone, full of little air holes and very, very light. You wouldn't, looking at this, this is probably a few ounces, maybe a pound. It would hardly be any weight at all because most of the interior is going to be air. And so what happens is that when this basalt was exposed to the vacuum of space, all of the trapped gases in the magma expanded, and the rock cooled so quickly that the gas was trapped as air pockets inside of the basalt. And so we're able to use this to kind of get a sense of what sorts of things were inside the rock at the time that it got solidified. Now, the highlands is made up of anorthosites, also some of them are called breccia. It's basically rock composed of broken fragments of minerals that are cemented together. So when you look at these things, they're basically looking very much like the cement of our sidewalks. Lots of little rocks that are held together chemically, but they're very fine-grained bits of shattered and pulverized rock that are all basically clumped together. Okay, so that's the end of my second section on the moon.